Okay, is that... Yep, that's stable enough. Oh, I have something new for you. This thing. Okay, do not stamp heavy objects on the desk with the new improvised camera mount. This is something I have stolen from work, but I'm going to take it back when I'm done with it. A while ago we decommissioned our library, and when it was decommissioned, the part of the security system was left in a big box. We had a big clear out not long ago, but after it was done I realised we'd forgotten to chuck out the library security devices. So I have two components of that, which I thought, I'll steal them, I'll do a teardown, I'll take them back in. So these are going back in the WEEE recycling. But it's a chance to see exactly how one of these library security things is built. This is what we had before RFID. It works using a combination of a sensitizer, a desensitizer, a set of barriers, and a tag placed in each book. The tag is a metal strip made of some exotic alloy. I don't know exactly how it works, that side, metallurgy magic, which can be magnetized and demagnetized. And it's got a tuned resonant frequency. At least I think this is how it works. The coils in the barrier generate a magnetic field that is... Really? Moment. Right. Tell you what, if I can make 500 views in this video, my next one will be scripted, and that won't happen. Where was I? Right, the barriers generate a magnetic field that oscillates, but not at the resonant frequency of the tags, close to it. So when the tag is placed within that field, and i.e. someone is stealing a book, it will mechanically vibrate. And because it's being driven very close to resonance, it will vibrate at resonance, and this will transmit a very, very weak magnetic signal, which the barrier can detect and set the alarm off. I think that's how it works. Well, to use this, you need a way of toggling the books between two states, in library and checked out. And to do that, use a desensitizer and a sensitizer. As you might imagine, the trick to sensitizing is a great big magnet, and to desensitize it, I would imagine a great big electromagnet. And this is the desensitizer. Really? I thought that was a sensitizer. Okay. Maybe I had the names backwards, but this is the thing that makes it magnetic. I think sets the alarm, so it sets the alarm off. I'm mixed up now. I'm not going to take this apart because it's riveted shut. But I imagine it's riveted shut because there is nothing in here, and I mean literally nothing, that could possibly go wrong. You can see by the warning mag labels it's magnetic, and sure enough it contains a great big magnet. That is quite a strong one. I think it's probably more than one magnet actually. Made by 3M Safety and Security Systems Division. Yes, 3M, the post-it people. Why is that image so dim? Made in USA, which is unusual. The more interesting part is this. The thing that makes these tags not magnetic. Now, I've not yet opened this up, but I have taken the screws out. You can tell by the warning on top that it is some kind of magnetic device, and it has instructions printed here. It says to take your book. I've got no books to hand, so pretend this box of grommets is actually a book. And you swipe it, it makes a loud sort of dong noise, and then your book is ready to check out. Now, I would guess that this is based around, see it's got a power connector there, would guess that this is based around a great big electromagnet, an optical sensor, which you can see here, probably reflective infrared, and a little board that does power supply for the logic, a timer, and a relay or a solid state driver to switch the big magnet on. And I'll give pretty good odds that the timer is a 555 chip. So there's probably not much in here. The power supply might just be a capacitive dropper and a load resistor. It could be that simple. Well, let's see. Up. How long's the lead cable? Plenty. Okay. That is a really, really big coil. And that is crazy big. Any residual magnetism? I feel a tiny bit. I wouldn't expect much because this thing's obviously been driven off of AC. So when you wave your book in front of it, it starts timing here. Dong. Might do it twice, so yeah. And the field from this will then demagnetize the book. Because it's an AC field, it demagnetizes rather than magnetize. That is labelled signal transformer. From position, I'd say it's more likely the power transformer. It just draws so little power, it doesn't matter. Bridge rectifier, 7812 regulator. So, yep, very, very little to the power supplies, but as little as you can get away with. I'm guessing these ones go wiggle, wiggle. There we are. Power, bridge, power, and these two to the coil, which also has a bridge on it. Okay, that makes sense. But you've got this selection of A and B terminals here. Tells me this is probably a dual voltage device, where they use the same board and coil in the US and European versions and just switch those wires around depending if they're going for 110 or 230 volt operation. So that's probably the timer chip there. MC145 8BCP 14538. Never heard of it. No, can't tell you on that one, so it's not a 555. Oh well, disappointed now. There is the sort of what I call the business end, some kind of protective coating on there. Surprising amount of stuff on the optical board, including is that LM555. There we go, I was right. LM555. And the other chip is a LM358. I know that chip. That is a dual comparator. So that's probably part of detecting the change in output from that sensor. Simple fixed threshold device connected to a timer circuit. This is about as simple as it could be. In fact, it's so simple, I would wonder what that chip does. That is really all there is to this thing. Right, I shall get this closed up and back to the recycle it goes. Because I've got no use for it. There's no parts in here worth scavenging. 7812s are pennies each on eBay when you buy them in bulk. Have I knocked one of the feet off? Oh well. Right. Where's the way to reach the stop button on here? There we go. No stop.